my YouTube channel Coding Gigs. So let's discuss and let's continue with the remaining topics. So before that, let's quickly recap what we have studied in the previous video. Okay, so first was the function definition, right? What is the syntax of a function? Okay, what is the return type of a function? Okay, and why, when do we use void? When do we use integer as a return type? When do we specify the return keyword? Right? How do we call a function in a program? Okay, and what are the four things that we need to keep in mind? What is the name? Okay, that four things would be the name of a function, number of parameters, the data types of those parameters, and the returned value by the function. Okay, which return value you are collecting. Okay, that we need to keep in mind whenever we are calling a function inside the main function, right? Next was why do we need a functions, okay, in our program. Next was the working process, how this working process overall goes. Okay, when do we execute this greet function? Okay, why do we call this as a callee? Why do we call this as a caller? Okay, so everything we have studied. Okay, which is a callee? A callee, this is greet. Greet is called as callee. Why? Because this is called inside the main function, and this is called as caller. Main function is called as caller because we are calling that particular function. Okay, function which calls is called as the caller, and the function which is being called is called as callee. Right. Now, before looking to the next topic, which is role of a stack in a function, I quickly want to discuss something. See, wherever we are using this type of a function where you are specifying as a return keyword, what I said was, and the other one is void. Okay, so we had a confusion, right? That when we need to use this type, okay, when we need to specify a variable, we need to store it, and we need to call this function. Okay, and here we are not using any kind of variable for calling this function, right? So always keep in mind that whenever we are using void as a function, we don't specify any variables. We simply call it. Okay, you just simply need to call this function like this. Okay, and whenever we are specifying a return as a keyword, anytime in the function, we need to either we can do like this, cout sum, directly pass, either you can call the function like this, 2 and 3. Okay, or either the previous one, that is you store the value in a variable and then you can simply print the value, okay, like this, cout answer. You can simply call the function in this way also. This is one alternative of calling a function which contains return as a keyword, and the other alternative could be simply use a cout as a statement and call your function. Okay, any of this will work, but here you cannot use cout because you are not returning anything, or neither you have specified the return keyword. Whenever you're not specifying any return keyword, always directly call the function. And whenever you are specifying a return as a keyword, okay, then you need to use this as alternative one, okay, where you're storing that return value in the form of a variable and then you're printing the variable, or else simply call that function which contains a return keyword using a cout statement. This too is an alternate. So this was one point which I wanted to discuss in this video. So let's move on to the next topic, which is role of a stack in a function. Now, what is a role of a stack? Okay, so we know that our functions, whatever we call, it starts from the execution starts from the main function. Now, main function is also a function, right? So from there, your execution starts. Okay, so here we use a stack. Okay, now stack is something, a kind of a storage area which holds the information about the active as well as the paused functions, including the function's information, entire function information, which could be the return address, the parameters that we're using, the number of variables or the number of lines of code that we have specified. So all the information of that particular function will be stored in the stack. Okay. So now let's see, whenever we have executed that particular function, when the execution is complete, from the stack that particular value will be popped out. Okay, so whatever I have said, I hope that you have understood little bit and there are some kind of confusions. So we will resolve that part. Okay, I'll just explain you with an help of an example. Okay, now see, this is your main function. Inside this main function, I'm specifying it over here. Okay, so here your execution starts. Here you have written some lines of code. Okay, then you call a particular function. Let's say A is a function you have been called. Now you will go to that particular A function. Okay, here A function has been called. You will go inside this A function. You will perform some lines of code. Here it is written. You will perform that. Again over here, another B function has been called. So this A functions, whatever value is there, variables are there, then return address is there, then parameters are there, everything, all the information will be stored in stack. First main function information will be stored, then A function's information will be stored in the stack. Okay, so the return address, the parameters, everything, the variables, everything will be stored. Okay, so now main function goes to a paused state. So that paused functions also information, the call stack is a storage area where it is stored. Okay, so this goes to the main function goes towards the pause state. Okay, because we hear that after A function, certain lines of code definitely would have been written. So until and unless you complete this part, you cannot move on to this part. Okay, after the A function has been specified, whatever the remaining lines are there, that you cannot execute until and unless your A function execution has been completed. Okay, so let's say here also B function is called inside A function. Now A function goes to a pause state. You go directly to B function. Okay. So inside B function, definitely you will perform certain kind of code. Once you are done with this code, you'll come back over here. Okay. So once the execution of B is done, what will happen? First, first main functions information will be stored. Okay. Uh, 1 minute. I'll do something over here. Hmm. I'll create a stack. Okay, so where do I need to create a stack? Let's erase this part for a while. Okay, here only I'll create a stack here. So this will be my stack area. Okay, here your B function will be called. Okay, your execution is done. B function execution is done. What happens is this is your stack area, the storage area, where your main function first information will be stored. This main function will go into a paused state because you're calling a function. Okay, inside the main function. So a function will come over here. Certain lines of code will be executed. Okay, the variables, what are the variables that are being used in the a function, everything this stack is going to store. Okay, all those informations will be held by the stack. Okay, again this a function goes to the pause state and you will call the b function inside the A function. So after here also certain lines of code will be there. So these lines of code will not get executed until and unless B function is has completed its execution. Okay. So B function will go, okay, it will call the B function, it will go over this space, all the execution will be done. Once B has completed its execution, this will be popped out from the stack. Okay, you'll come, the line of control comes over here. Okay, whatever the remaining code of the A function was there, that will be executed. It will come inside the main function. It will return the values, okay, whatever the execution process was done. Once the execution process of A function is done, this also will be popped out. And then the last lines of the code over here, which was not getting executed because the A function went to the paused state. Once the execution is done, the remaining lines of main function of the remaining lines of code in the main function will be executed. And then the entire main, once all the lines of code are been executed, the execution process is done, the main function will also get popped out. So what happened was initially main function was called. Main function information got stored. After that, A function information got stored. After that, B function's information got stored. Once the execution of the B function got completed, it got popped out. Similarly, A function's process got popped out. Right. That is why we call it as stack, which means last in, first out, LIFO. So this is the role of a stack. Now we are going to see with the help of example or with the help of a code. Okay, whatever I have explained you till now in here, that will be performed with the help of a code over here. Okay, so I'll just comment this part. Fine. So what I'm saying is I'll call a function. Okay, over here. For that I need to create a function. So void a function. Okay, so here B function is called. Okay, and here you'll print certain kind of statements. Let's say B is called. Okay, inside B function, you're calling C function. So you'll write certain kind of statements. C is called. Okay, void C function, you'll say C out inside C. Inside C, here you can say inside B, and here you can say inside A. So what will be the execution process or the how you can say sequence of this particular code, how it will go? Let's see what output we are getting. Void C expected out semicolon. Okay. So inside C, inside B, inside A. But I had called A function, right? So A function, this code would have got executed, then this code, then this code. Why like this? Why is the sequence going on like this? This is what we have discussed over here. What happens is in this code, main function got executed first. In the stack, your main got stored. Okay, the control goes over here. Main is now goes into the paused state. All the information of main will be stored inside the stack. Okay. Next, a function will be called. Okay. Now a function will be stored over here after main. Right. All the informations of main function will be stored. Okay. Whatever lines of code is there, what the variables we are using, the return address. Obviously, then now after specifying here the a function, now this a function also goes to a paused state. Why? Because we are calling b function. Now b function will execute, it goes to c function. C function will complete its entire execution process. After this, from here the C function will be popped out. Okay, and the control goes over here. And then this line of code will be printed. First, this line of code got printed, entire execution process got completed. You got this answer inside C. You came over here. Inside B got printed because C function execution process was done and it was popped out from the stack. Okay. Similarly, inside A got printed and then main function also got completed, and this is the role of a stack in a function. This is what we call a role of a stack in a function. Okay. Next is what is local and global variables. So already we have studied about scope of variables while we were discussing about loops, right? So we studied what is a particular scope, right? Whenever we try to specify certain kind of variables, till how much part it is accessible, till how much part the compiler will get to know that, yeah, the variable of this particular is so and so. Okay, so that is called a scope. So inside scope, I had given you a little bit context or small context about local and global variables. Again, we are going to revise it in functions. So what is a local variable? A local variable is specific to a function or a block of code, and it takes priority over variables with same name in wider areas of the program. It can only be accessed within its defined scope. So always remember, a local variable is a variable that is only specific to a particular function or a block of code, and it can only be accessed within its defined scope. That is called as local variable. And global variable can be accessed and modified anywhere in the program. Okay, unlike local variables, where only it is restricted to a particular function or a block of code. Okay, so again, I'll explain it with the help of an example. Let's say, uh, I'll comment this part also, as well as this part. Okay. Now I have created a variable, let's say int a is equals to 2. Right? I create a function void print a. Okay, and a is equals to 3 and cout a. Okay, I call this function print a. Now let's see what happens. A was not declared, right? So integer a. So 3 got printed. Why 3 got printed? Because 3, the value of a over here is restricted only this amount of block of code or inside that function. So this is local variable, right? So only this much part, this much area you can access the variable a. Outside this area, if you try to access the value a, you're not going to get. Whereas if you try to access the value of a over here, here also it is restricted to this amount of block, this a value. Okay, so this is called as a local scope. This is a local scope. This is a local scope for variable a, and this is a local scope of a variable a. Now let's say I try to create another variable, global var is equals to 10. And I try to access here also and here also. Will I be able to access? Let's check. Cout global var, and here also cout global var. Let's see whether we are going to get an error or the required output. So 3, 10, 10. That means this is a global variable which is accessible in this part also and accessible over here also. So this is the main difference whenever we are using a variable in terms of local and global. Okay. So I hope you have understood this particular thing, right? So we have seen this part. Now let's move on to the next topic, which is scope of a variable versus lifetime of a variable. Now we know what is a scope of a variable, which means that it determines where in the program the variable can be accessed. Okay, that is called as a scope of a variable. And lifetime of a variable means how long its memory remains valid during the program execution. That is called as a lifetime of a variable, right? Next is pass by value method. Now what is pass by value method? Now if you clearly look on to my screen, okay, you will be able to see that I have created a function and I am calling that function inside the main function. Always remember, the function contains two types of things we need to keep in mind. One is actual parameter and the other is formal parameters. Okay, here we have defined two values, right? A is equals to 10, B is equals to 20. So this is called as actual parameters. Okay, and this value is being copied inside this function which is called as increment function. Okay, the value 10 and 20 got copied. Okay, that the value which got copied is called as a formal parameters, and the value which are you are using as a parameter over here, this is called as actual parameters. Okay, these are actual parameters, and this is the formal parameter. Okay, now what does pass by value mean? Pass by value means that you are creating a copy of that particular variable or a value, and you're using that copy. Okay, to perform certain kind of calculations, and whenever you're performing that calculation is not affecting to that original value, that is called as pass by value. Now I can help you with the example. I can tell you with the example. Let's say you have two receipts, okay, and one of the receipt is with you, and the other of the receipt you have given it to your friend. Okay. Now both the receipt contain same copy. Receipt 1 has one copy and receipt 2 has the same copy of receipt 1. This is my receipt 1, this is my receipt 2. Here you have one copy and here you have the second copy. The copy of this, whatever contents you have this in this receipt, this exact replication has been done in this receipt, and this receipt is provided to your friend. Okay, now suppose your friend tries to make changes over this receipt. So that will be reflected only to your friend. Here, any changes would not be done. So this is your receipt 1. This is an example of a pass by value. Okay, so we have studied about the role of a stack, what is local and global variables, what is scope of a variable versus lifetime of a variable, and what is pass by value. I hope you have understood this video. So please like, share, and subscribe to my YouTube channel. And if you have any doubts, please comment it, and I will try to resolve as soon as possible. And the codes and notes will be provided to you. Keep learning. Thank you.